problem setting, you have to complete the table for a savings account in which interest is compound continuously. So first of all, you're going to need the formula A equals P, E to the R and to the T. And what basically A represents is the amount after the years have passed. P represents the initial investment. E is the log. R is the annual rate, and T is the time in years. So first of all, P is going to have to equal 10,000 because that's the initial investment, and the E would just be right next to it. And after the E, you're going to have to find the R, which is going to be the annual rate. So the annual rate, you would have to make that in a decimal, so it would be 0.035 rather than 3.5%. And then after that, you would have to find the years, and the years would be 10. Once you've gathered all up the information, you're going to have to solve it out, work it out. So once you've found all your variables, you're going to have to plug it into the formula that we said before, which is A equals P, E to the R and the T. And once you've gathered it all up and plugged it in, you're going to get A equals 14,190.675. That would be your answer for the amount after the 10 years. Okay, so first of all, we want to find the time to double. And basically P is going to equal 20,000 because you'd have to double the initial investment. So 20,000 equals the initial investment, which was 10,000. And so you'd put E next to it, and then you'd put the annual rate, which is 0.035. You'd have to keep it as a decimal. And then what you basically want to find is the T. That's the most important thing. So first of all, what you want to do is you want to divide both sides by 10,000. And after that, you'd be left with the 2, the E, the 0.035, and then the T. After that, you would have to find the natural log of both sides, leaving you with 0.69314 on the left side and 0.035 T on the other, or X, doesn't matter your variable. And after that, you would divide both sides by 0.035, giving you your answer, which is X equals 19.804 for the time. So the next problem is problem 29. In problem 29, you're going to have to use the formula P equals 134.0 E to the K and to the T. And so what you want to do first is plug in 180, and note that's going to be in thousands, so you just keep it as 180 equals 134.0 E to the K and the T. And for T, you would plug in 10. After that, you would divide 134 to both sides, giving you, which would give you 1.3432. And once you divide it on the other side, you would take the natural log of both sides, and it's important to do that. So you would be left with K to the 10, K10 on one side, and then 1.34. Well, you'd just be K10 on one side, and then you'd be left with 2.950. And after that, you would divide both sides by 10. Once you figure that out and divided both sides by 10, you will be left with your final answer, which is 0.0295. For problem B, so for problem B, you're going to use your model to predict the population in 2010. Keep in mind for K, you're going to use the same number you got for the answer to problem A. So K would equal 0.0295. And it would, for T, it'd be 20 years because you started out in 1990 and jumped to 2010. So once you set up your formula, all it is a matter of plugging in your calculator, and you would be left with your final answer. And your final answer would be P equals 241.734. So the next problem is problem 39. So problem 39 is conservation organization releases 100 animals of an endangered species into a game preserve. The organization believes that the preserve has the carrying capacity of 1,000 animals, that the growth of the herd will follow the logistic curve. So for problem A, it's just asking what is the population after 5 months, and this problem is just a matter of plugging in your variables. And so T, it's where T is measured in months. So the formula we're going to use is T equals 1,000 over 1 plus 9 E to the negative 0.165 T. So all you're basically going to do is find your variables, plug them in, and then you basically solved part A. So this is problem 39, part C, so which it involves some graphing. And note that this is a different calculator, it's a TI-85.